Hey everybody, I want to do a quick review of scientific notation in the metric system. And I really want to focus this on metric system converting things into scientific notation. And then when we are working with scientific notation, I specifically want to work with multiplying and dividing numbers. So we're going to go over kind of a quick review. And I think I want to start with basics of scientific notation. So let's first start off by just putting numbers into scientific notation, all right? So let's start with a couple numbers. I want to choose two, a big one and a small one. All right, so I have two numbers here, 3,100 and 0.00760. And just because I'm not quite sure where you're at, but just if I want to put these numbers in scientific notation, the first thing I go and do anytime I do this is actually take a look at where is the decimal in this number. And even though there is no decimal here, I know that this is where the decimal has to be. So then I will go and basically say, if I want to put this number in scientific notation, I always like to have a situation where I have a number and then a decimal place and then another number. So I'm going to go and try to move this decimal place until I have this type of configuration. And that basically means this. I'm going to go move over 1, 2, and then 3 places. And that'll put the new decimal point right in between the 3 and the 1. So when I go and write this, I'm going to end up with a 3.1. Now, then I've got to put in the times and the 10, but how many places? A lot of people look at this and they say, oh, there's two zeros, so it has to be times 10 to the 2. But did I really just move the decimal place 2 places? No, I actually moved it 3 places. Starting from here, 1, 2, 3 places. So the exponent in my scientific notation is actually 3.1 times 10 to the 3. Okay? The same type of thing can happen here. I want to put this number in scientific notation. This is a decimal number, which means the exponent is going to be a negative. And again, I want to move my decimal around until I have this type of situation, where I have a number and a decimal and then another number if need be. So in this case, to get my decimal in between, and it looks like if you guys are kind of ballparking it here, the decimal should go between the 7 and the 6. I need to move this 1, 2, 3 places before that happens. So if I do that, I will get 7.6, and then don't forget the 0 that's after this. The 0 is important after a while. 7.60 times 10 to the number of places I moved it. Not the number of zeros, the number of places I moved it. In this case, I moved the decimal 1, 2, 3 places, so it becomes 10 to the minus 3. Now, when I look at either of these numbers, they technically the 3100 and 3.1 times 10 to the 3 mean exactly the same thing. While it may be easier for you to look at it in an actual number notation, I guess if you want to call this number notation, I'm looking at this in 3.1 times 10 to the 3 means exactly the same thing. And 0.00760 may not be that hard to write, and okay, you may want to leave it as a decimal number, but to me, I look at 7.60 times 10 to the minus 3, and it means exactly the same thing. Exactly the same thing. Now here's a situation where you really might want to choose to write it in scientific notation. Okay, let's say I have a gigantic number, and this is, let's see, 150, this is 150 trillion, right? Now, can you imagine trying to punch all these numbers, all these zeros into the calculator over and over and over again if you had to do this as a math problem? So this is a problem that's screaming out for me to do and put it into scientific notation. So remember, I like to see the format a number, a decimal, and then another number. So what do I have to do to get that to happen here? And you guys may be looking and you're seeing that that situation will work if I put the 1, the decimal between the 1 and the 5. So how many places do I need to move this to get that to happen? Well, I need to go 1, 2, 3, 4. I have 6, 7, 8, 9, 10, 11, 12, not done yet. 13, not done yet. 14. So I need to move this 14 places. So my number in scientific notation becomes 1.5 times 10. And because it's a big number, 10 to the 14. Okay, the same type of thing happens with really small numbers. I mean really small numbers. So here's a really small number. I don't even know what this number means. Sometimes it represents the amount of money in my bank account, but this number would be much better in scientific notation. And to get there, I need the decimal point to be somewhere between the 8 and the 5. So to do that, I'm obviously going to have 8.56, but it's going to be times 10 to the, wait for it, move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So 8.56 times 10, that's a terrible 10, to the minus 10. I did do that right? Yep, did that right. I just had to double check. So for me, scientific notation really, comes into all of its glory when you're working with really big or really small numbers. All right, so this is putting numbers into scientific notation. Um, Look, we can spend time going back the other way, but right now I wanna kind of move on. Okay, so I want to do some math here. I have two numbers in scientific notation, and I want to multiply them. Now, if you guys remember back, there's a number of ways you can do this, and I recommend you punch this into your calculator directly. But one of the kind of shortcuts you can do with any type of process like this is simply take the numbers that's found out in front, take those two things, and multiply them. So if you take 1.5 and multiply it by 3.2, that will give you the initial number that's going to come out in front of whatever your answer is. Then, if you remember, what you have left is 10 to the 8 times 10 to the 8. If you remember what to do there, so this is basically 10 to the 8, let me put this in parentheses. So I just basically took 10 to the 8 times 10 to the 4 and put them down here. If you remember, when you're multiplying things in exponents, the secret to getting the answer when you're multiplying them is to add the exponents. So to do this problem, you would take 1.5 times 3.2, and then your answer is going to be times 10 to the 8 plus 4 is going to be times 10 to the 12. Okay, so a quick way to solve this problem, just by multiplying the numbers out in front, and then by adding the exponents, you get 4.8 times 10 to the 12. And this works every single time. Remember, if you're dividing the exponents, then you actually subtract. So let me give you an example like that. Okay, so this example, I don't know where the divide symbol is. To get this answer, you basically take the 1.5 divided by 3.2. All right, so if I pause and get okay, the answer for this part is 0. Whoops. Okay, so I rounded, I get 0.47 times 10 to the, if you remember, in this case, when you're dividing two numbers in scientific notation, you actually subtract the exponents. So this is going to be 0.47 times 10 to the 8 minus 4, or simply just times 10 to the 4. Now, you get an interesting situation to pop up here. If you gave this to your math teacher is going to yell at you and said, change it. Technically, this answer is correct, and you could tell your math teacher that I said so. But if you want to make your math teacher happy, you can basically put this number into something where you get a condition where you have number, decimal, number. So here's a general rule. Anytime you want to make this number bigger, and that's what I want to do. I want to multiply this number by a factor of 10. You have to reduce the exponent by 1. So in this case, to get 4.7 times 10, I have to basically go and decrease the 4 by 1, and I'll get 4.7 times 10 to the 3. So 4.7 times 10 to the 3 is exactly the same mathematically as 0.47 times 10 to the 4. Don't let anyone tell you different. They're exactly the same, right? All right, well, we're basically just solving these problems by, using kind of a math trick. But what happens if you actually want to plug these things into a calculator, which is something I really want you to do. All right, now many of you will have this type of calculator. This is a Texas Instruments calculator. And let me just pause and throw some numbers up here. Okay, so let's say I wanted to do this problem again. Many of you are going to use the time-tested route. Let's say I want to plug this number into the calculator. You are going to do something like this. You're going to type in, and I'm going to give you like order of operations, exactly what I'm going to type in. You're going to type in 1.5, and then you're going to hit the times button, and then you're going to hit 10, and then you're going to hit the caret button, and then you're going to type in 8. And there's absolutely nothing wrong with that because everything you see here represents 1.5 times 10 to the 8. Well, I want to show you something different. And I need you to look on the calculator right here. Let me change color real quick to change it to yellow. And if you have this specific type of calculator, you notice obviously not the x minus 1. That's not what we're looking for. But this button here that says EE. You have to get there by hitting second function first and then EE. But what EE does is it completely takes care and eliminates all of this nonsense you see. Well, let me just change that. It eliminates all of this nonsense. It eliminates 1, 2, 3 more steps that you actually have to take. So not only that, but if you want to do more complicated problems like dividing numbers with scientific notation, you don't have to use parentheses anymore, right? So let me just show you how this works. Obviously, some people have a calculator like this already. Some people have a calculator and it literally has a button that says EE. You don't have to go to second function first. Some people have a button that looks like this. The button on their calculator actually says this, and that means the same thing as EE. Some people have a button that says EXP, and all three of these things mean exactly the same thing. And it saves you from doing 1, 2, 3 extra steps on your calculator. Technically 4 because you got to plug in a 10. All right, so I digress. Now I want to go back and I want to type in this first number again in scientific notation using the EE button. And here's the order of operations. Um, all right, so it's not necessarily as important when you're multiplying two numbers, but more important when you're dividing. But here's what I'm going to do. I'm going to go and I'm going to type in on the calculator the 1.5, and then I'm going to hit not the times button. I'm going to go over here and hit second function. So I'll just type it in. You're obviously not typing this in on the calculator. You're going to hit second function, and then you're going to type in EE, and that basically does all of this stuff for you. Then you just put in the exponent, which in this case happens to be 8. So you're going to go 1.5, then second function, then EE8. And it will probably write something on the calculator screen like this, just so you know you're right. 1.5 E8. And don't ask me why. I'm sure there's a legitimate reason why, but 1.5 E8 is exactly the same as 1.5 times 10 to the 8. It's just in calculator speak, whatever that language is. All right. So this is so you know you have the right answer. Now, once you've actually punched this in, you don't have to put parentheses around it. You can just hit times and then punch in the second number, which is going to be 3.2, second function EE, and then the exponent 4, and then you hit equals, and it's going to give you the exact same answer that you got before. All right. The EE can save a whole ton of time, especially when we get to the next type of problem. All right. All right. So here's the next type of problem. And it doesn't seem like it's as big a deal, but you know what? I want to be a little evil right now. I want to change this. I want to change this to a negative exponent. Let's go negative. Um, how about negative 14? Right? And obviously I have to go and I have to change all these things to exponent, which I probably could have just turned off the camera for. Now I need to go back and do it again. There we go. So that's better. 2.3 times 10 to the 14. Yep. All right, so this problem, the order of operations using the E really helps. This is the type of problem normally before you would have had to use parentheses around, but you don't have to use parentheses anymore. So try it yourselves when you're doing this on the calculator. You basically type in 1.5 and then second function EE8, and then without hitting parentheses, hit your divide button, and then 3.2 EE, whoops, that was a very strange E, hold on. Okay, so the last step here is 3.2 times 10 to the negative 14. The only thing you have to do is when you put in the exponent for negative, some people use the subtract sign. And it's actually not the correct button to use. You're not going to use the subtract sign. When you want to change the sign of a number, you actually have to use this button down here. So on your calculator, you're going to hit this button first. And I'm not putting parentheses around it. I'm just telling you which button to hit. And then you're going to punch in your exponent. And then if you got the answer correct, you should have gotten. Okay, we're back. So the real question is, I know some of you basically you didn't use the E button. I know you did because everyone's always resistant to change. So the question is, which answer did you get? Did you get the answer on the top? Did you get the answer on the bottom? Only one of them is correct. If you got the answer 4.69 times 10 to the 22, you are correct. So here's what happens. How do you go and basically get the same first number but the different exponent? This is what your calculator sees. If you were using the times 10 to the caret button and you're not using parentheses around the denominator of this answer, and that in this case you'd have to use the parentheses around this side only if you're using times 10 to the 8. If you didn't, it takes the first number, 1.5 times 10 to the 8, it divides it by 3.2, and then it stops. And then it goes and it multiplies the entire answer by 10 to the negative 14. So this answer is incorrect. The answer on the top is correct. can't stress enough how important the EE button is to help you save time and get more problems correct. I see more people refusing to even try, even attempt problems because simply of manipulating problems on the calculator. All right, I'm going to end this one right now. Instead of I'll talk about metric system in another video, but this one is basically scientific notation review. This is definitely not one to skip if this is not something you've done in a while. All right, get going.